This is Lab 10, Semiconductor Light Sources. I'm Owen Litz.
And I'm Richard Pang, and this is for our TA Lam Nguyen. Part A, Physical Properties and Spectra. The goal of this part of the experiment was to observe the light-producing diodes and LED and laser diode sources. The sizes of the diodes were measured using a pixel calibration to a real-world measurement. Here we can see the physical properties of the LED and laser diode from the images, and we have a table below with the dimensions for all LED types in the laser diode, where the width of the laser diode is the cavity length. For our calibration factor, we had 1 millimeter per 173 pixels. These are the spectrums for the laser above lasing threshold and the laser at lasing threshold. And we can calculate the longitudinal mode spacing by delta nu cavity equals C over 2 on L, where C is the speed of light, N is about 3.5, and L is the length of the cavity. Using our data, we find that delta nu cavity equals 5.93 E10 Hertz. And from the OSA spectrum measurement, we found that delta nu cavity equals 5.93 E9 Hertz, which is an error of about 1 order of magnitude. These are the spectrums for LED. On the left, you can see from our experiment, and on the right is what we Googled. And we can see that the spectrum of our LED is slightly lower for the peak than the Good LED spectrum, but they're about the same.
Divergence beam spacing. The goal of this part of the experiment was to determine beam profiles and divergence of the laser diode and LED. The polarization of the different diodes was also determined. This is the results for the LED with voltage versus angle, and the results look to be Lambertian. These are the voltage versus angle of the laser, one when it was horizontal in the top left, and one when it was vertical in the bottom right. These are the results for the second section of Part B, with a polarizer being placed in between the laser diode in the center and the LED in the center. For the LED, on the right, there was no change in voltage based on the angle of the polarizer, which means the extinction ratio is 1. And for the laser diode, there was a change in the voltage produced with a change in angle of the polarizer, and the extinction ratio turned out to be 44.5.
Part C, power output. The goal of this part of the experiment was to determine the effect of the drive current on the power output, and this was determined for both the LED and the laser diode using an integrating sphere.
The results for Part C, with the LED in the integrating sphere, it quickly shot up and then it plateaued at around 60 milliamps. This was expected. For the laser diode, it didn't do much until around 30 milliamps, and then it finally started lasing, and the power output is seen to spike. And then in the bottom, that is the spectrum of the laser diode.